Hello everyone, I am Dr.VRAO-PHYSICAL. Today I am here with a new chapter, that is chemical kinetics. That is chemical kinetics. Right? Before we are going to learn chemical kinetics, let us know what reasons led to the chemical kinetics, what is chemical kinetics, and how this why we need chemical kinetics, right? Before we are going to learn chemical kinetics, let us know what reasons lead to the chemical kinetics and what is chemical kinetics and why we need chemical kinetics, right? Up to this lecture, we dealt with thermodynamics. Thermodynamics predicts that whether a given chemical reaction is feasible or not, right? I repeat, thermodynamics predicts that whether a given chemical reaction is feasible or not. For example, thermodynamics predicts that hydrogen and oxygen react to form water and that reaction is feasible, right? That is, thermodynamics predicts that whether this reaction, that is 2H2 plus O2 gives rise to 2H2O, right? So thermodynamics predicts that whether this reaction is feasible or not, right? But when we carry out the experiment, when we carry out this chemical reaction, we find that this chemical reaction takes place very slowly. That means it takes much of time, right? And it takes much of time unless if we are willing to wait indefinite time, right? That means this reaction takes place so slowly that unless we are willing to wait, that means we need to wait indefinite time. That means this reaction takes place very slowly, right? And another example is, for example, thermodynamics predicts that decomposition of N2O4 takes place, that is decomposition of N2O4 is feasible and it takes place instantaneously, almost instantaneously, right? And the second reaction is N2O4, decomposition of N2O4, that gives nitrogen dioxide gas, right? So thermodynamics predicts that whether this chemical reaction is feasible or not. That is, thermodynamics predicts that this reaction is feasible almost, and when we carry out this reaction, we find that this reaction takes place almost instantaneously. In fact, the decrease in free energy, for this reaction, decrease in free energy, which is a measure for spontaneity of a reaction, right? Already we know that decrease in free energy is a measure of spontaneity, right? That is, when this reaction is carried out and when we find out the decrease of free energy of this reaction, that is decrease in free energy of this reaction is far less than the reaction for reaction between H2 and O2. That means, let me explain. That is, we know that a decrease in free energy is a measure of spontaneity. That is, the higher is the decrease in free energy, greater is its spontaneity. I repeat, higher is the decrease in free energy, greater is its spontaneity, right? Higher is the decrease in free energy, greater is its spontaneity. When we compare the decrease in free energies of these two reactions, that is the decrease in free energy of this particular decomposition of N2O4 is far less than the decrease in free energy of reaction between H2 and O2. That means decrease in free energy is very less for this reaction. Decrease in free energy is very less, far less than this reaction, that is decrease in free energy of this reaction is more. Decrease in free energy for this reaction is more, that is formation of water, and for this reaction decrease in free energy is more, and for this reaction decrease in free energy is less than that reaction. But in practice, that is when we carry out these two reactions, this reaction takes place very slowly, but this reaction takes place almost instantaneously. But we know that decrease in free energy is higher is the decrease in free energy, greater is its spontaneity. Then greater the decrease for which reaction decrease in free energy is greater? Decrease in free energy is more for this reaction, but okay, the decrease in free energy value is less, that is decrease in free energy is less for this reaction when compared with the decrease in free energy of this reaction. So based on that decrease in free energy of that particular reactions, this reaction would takes place spontaneously, but this reaction does not takes place spontaneously, that is it takes lot of time. But this reaction, that decrease in free energy for this reaction is less, but this reaction takes place spontaneously, that is instantaneously. So from these two examples, we can say that there is no correlation between thermodynamic feasibility and rate of chemical reaction, right? From these two examples, we can say that there is no correlation between thermodynamic feasibility and rate of a chemical reaction. In fact, the rate of chemical reaction depends on energy factors and structural factors, right? The rate of a chemical reaction depends on energy and structural factors, but that was not quietly, or but those factors are not quietly explained by thermodynamic quantities, right? But that those quantities, that is those quantities are not uniquely described by thermodynamic quantities, right? Thermodynamic quantities describes that whether that chemical reaction is feasible or not. But when we compare the thermodynamic quantities for these two chemical reactions, the decrease in free energy is more, but this reaction takes place slowly. The decrease in free energy is low when compared to this reaction, but this reaction takes place very instantaneously. Okay, so therefore therefore we can say that there is no correlation between thermodynamic feasibility and rate of a chemical reaction. In fact, rate of a chemical reaction depends on structural and energy factors. Okay, therefore we need another branch of chemistry that deals with rates of chemical reactions, right? So chemical kinetics, therefore chemical kinetics is a technique. Chemical kinetics is a technique which is complementary to thermodynamics. Thermodynamics measures whether that thermodynamics predicts that whether a chemical reaction is feasible or not, but chemical kinetics measures what is the rate of that reaction and how much time that it will take to complete. Therefore, we can say that chemical kinetics is a technique complementary to thermodynamics. Therefore, we can say that chemical kinetics that deals with measurement of rate of chemical reactions, under given conditions of temperature, pressure, and concentration. Right. So, chemical kinetics deals with rates of chemical reactions under the given conditions of temperature, pressure, and concentration. And this and moreover, the chemical kinetics has also been useful in determining the factors which influence the rate of chemical reaction and mechanism also. Right. Chemical kinetics has also been useful for determining the factors which determines the rate of reaction and mechanism. Right. Therefore, and moreover, one more important point in chemical kinetics is, and the study and the this chemical kinetics has also been useful in working out the conditions for getting maximum yield for several industrial products. Okay, this is the main advantage from chemical kinetics. So, chemical kinetics has also been useful in working out the conditions for getting maximum yield of for several industrial products. Okay, we have a lot of industrial products. Okay, so how can we get that more quantity of that industrial products? We will come to know when we have sound knowledge of chemical kinetics. Definitely, we will come to know how to get maximum yield of that industrial products, right? And therefore, thermodynamics. Which is a measure of or thermodynamics which yields driving potential. That is a tendency of a system to change from one state to another state. That is, thermodynamics predicts that whether the system is changing from one state to another state, whether that system has a tendency to change from one state to another state or not, right? Therefore, thermodynamics is a foundation upon which chemical kinetics is built. Okay, so when we are supposed to measure the rates of chemical reactions, we need a driving potential, that is whether that chemical reaction is feasible or not. We should know that thing first, that is whether that chemical reaction is feasible or not. Okay, therefore, thermodynamics gives foundation upon which chemical kinetics is built, right? I hope you understand the significance of chemical kinetics by this lecture. In the coming lectures, we will deal with fundamental concepts of chemical kinetics. Thank you. Thank you for watching.